Hello there, this is Ms. Page, and in this lesson we are going to talk about how we divide two complex numbers. So in an earlier lesson in this unit, this is part of our Unit 1, we learned about complex numbers, that they have the structure of a plus bi with a real part and an imaginary part, that if one of those two parts is a zero, then we have two subsets, the set of real numbers and the set of pure imaginary numbers. So when we divide complex numbers, any of those three different types of complex numbers can be part of it. First off, though, before we get into division, we are actually here in this lesson going to finish up a little bit about multiplication that wasn't done in the previous lesson. So first off, prior knowledge, you have learned how to now multiply two complex numbers by distributing twice. And so here we have the two complex numbers, 2 minus 5i and 2 plus 5i. The structure of these, where the first two parts are the same, they're both positive 2, and the second parts are opposites, one's a positive 5i and one's a negative 5i. We call that structure conjugates. And later on in this lesson, conjugates is going to be very important to us in division. So when we multiply, we distribute twice. So we take this 2 and distribute it to the second complex number. Then we take that negative 5i, distribute it to the second complex number, and we have our 2 times 2, which is 4, 2 times 5i, which is a positive 10i, negative 5i times 2, which gives us a negative 10i, and then we've learned to be super careful here. We have a negative 5 times a 5, which is negative 25, and we have an I times an I, which is an I squared. And then we have to simplify. So our positive and negative 10i would add to 0, and our I squared, we have learned, is equal to negative 1. So we have here is a negative 25 times a negative 1, which gives us plus positive 25 to add to that 4. And so notice that when we multiplied these two conjugates together, what we ended up was with a rational number of 29. That's going to be super important in our division procedure. All right, so now, again, before we jump into the division, which is the main objective of this lesson, we're going to finish up a little bit about multiplying, here specifically how we go about multiplying three complex numbers. So one of the big things about multiplication that you need to understand is multiplication is what we call a binary operation, meaning that you really can only multiply two numbers at once. So we have three numbers, three complex numbers in the a plus bi form. We have to multiply only two of them together in our first step. Which two, remember, would not matter. That's because of our properties of the associative property and the commutative property, which say that we can change the order of our factors, we can group them any way we want to. So we can do the first two first, we can do the last two first, or we could do the first and the third one first. Depends on what we feel would be easiest. In this problem, I am going to choose to multiply my last two together first. Personal choice. The number's a little smaller. I decided I want to start with smaller numbers. So I'm distributing twice again. So I have to multiply the 4 times the 3 minus 1i, and I have to multiply the positive 2i times the 3 minus 1i. The ones are optional. That gives me 12 minus 4i plus 6i minus 2i squared. And this, of course, again is negative 1. So I have negative 2 times negative 1, which gives me plus positive 2. So I have 12 plus 2, which is 14. And then my like I terms give me a plus 2i. So now I have to realize I have to take that complex number answer times my third factor of the complex number 9 plus 6i. All right, so now I am looking at multiplying or distributing the 9 to the 14 plus 2i and the positive 6i to the 14 plus 2i. Now you should not be using a calculator here, so you just kind of have to, maybe slow down a little bit with something like 9 times 14, or go over to the side and do it this way. We know that 9 times 4 is 36. And then we have 9 plus 3, which would be 12, so that's 126 plus 18i. Then we have our 6i times 14. So again, maybe you can do that in your head. If not, you can use some margin space. Do the 14 times the 6, which is 24, and 8. Just don't forget the I factor, so plus 84i. And then we get plus 12i squared. Again, our I squared is a -1, and 12 times -1 is -12. So we're going to add that -12 to this 126, which 126 minus 12 would be 114. So we get 114, and then we have to add our I terms. So we're looking at adding the 84 and the 18, and that gives us 102. So plus 102i. And that then is the result. And notice it's a new complex number. When you multiply complex numbers together, your answer should always be a complex number. It might be one of the subsets of complex numbers, such as a real number or a pure imaginary number, but it's still a complex number. All right, here is a practice problem with this type. Whoops, that wasn't supposed to happen. Here's a practice problem for you to try. So pause your video here, give this one a try, and then come back to check out the answer. Let's take a look at the result. So in this problem, and you may not have done your work exactly the same, but you should have the same answer of the complex number 20 minus 80i rather. In this problem, it's chosen to, in the first step, multiply together the last two, like I did in the example, and that work is shown here. And that ends up with the complex number -2 minus 26i. And then taking that -2 minus 26i times the third complex number 3 plus I gives us the final answer in this particular work. All right, so now we're going to get into the main objective of our lesson here, which is dividing two complex numbers of any type. And as I mentioned earlier, so conjugates, the structure of two conjugates is that they would have to have the same first terms. And the types of conjugates we're looking at are these two types, but they do occur in other types like irrational numbers and binomials in the set of polynomials. So here we notice that the first terms are both 3. Here we notice they are both -2. Then our second terms in conjugates, as I earlier said, are opposites of each other. So here those opposites are positive and -4i. In this second complex number, the opposites are -5i and +5i. We saw in the beginning of this lesson that when we multiply two conjugates together, that we get a rational number. And that's very important because when we divide two complex numbers, the procedure that we use is called rationalizing the denominator, which means that when we are done with our big math part, that the denominator needs to be a rational number. But it'll start off as some sort of complex number that involves an I somewhere. And so for us to be able to get rid of that I factor and have only a rational number left, we need to multiply our denominator by its conjugate. But you can't just multiply a denominator by a number. You've got to multiply by a ratio that's equivalent to 1, which means you have to multiply the numerator and the denominator by the same number in order for your new fraction or ratio to be equivalent to what you started with. So the way we do that is we use the conjugate of the denominator, and we multiply both the numerator and the denominator by that conjugate. And that's what this is saying here. So we do the multiplication, we multiply the two numerators together, and we multiply the two denominators together. And then once we're done and we've simplified all of the stuff that we can simplify, then we want to make sure that our final answer is in our complex number form, which is our a plus bi form. And if we have any fractions that have common factors, like we end up with 6/10, we would reduce that to 3/5. So we put it into its final simplest form and in a plus bi form. All right, so here is our first example. So here we're taking two complex numbers. 10 is a complex number that's also a real number, which is rational, and the denominator that we're dividing by is -6 minus 2i, a complex number of a plus bi form. So what we need first is the conjugate of our denominator, -6 minus 2i, and that conjugate would have the same first term, and that would be a -6, and its second term would be the opposite. So instead of a minus 2i, we'd have a plus 2i. So we are going to take the 10 and the -6 minus 2i, and we multiply by that ratio of 1 that's created using the conjugate here, so that both numerator and denominator are multiplied by the same thing. So now I distribute. 10 times -6 would be -60, and then 10 times 2i gives me plus 20i. Here in the denominator I distribute twice, so I have -6 times -6, which is 36, -6 times 2i, which is -12i, -2i times -6, remember a negative times a negative be a positive, so we get positive 12i, and then again be super careful with this last product. We have -2 times 2, which is -4, and we have I times I, which is I squared. So now simplifying my denominator like we've done in multiplication problems, this is -4 times -1, which is a positive 4, and -12i plus 12i would be 0, so our denominator is going to become 40. So now what we have is -60 plus 20i over 40. Now what we're going to have to do is split this into its a plus bi form. So remember, the 40 is a common denominator for both terms in the numerator, the -60 and the 20i. So we get -60 over the denominator of 40 plus 20 over the denominator of 40 times I. And then reducing our fractions here, which have common denominator here of 10, that would give us -6 over 4, which then further reduces with a 2 to -3 over 2. And this becomes, reducing by 10, 2 over 4 times I, and then 2 over 4 reduces to 1/2 times I. So there is our final answer to the division problem, which is a new complex number, and we've got it in its simplest a plus bi form. All right, I would recommend you pause the video here and try this practice problem. Come back when you're ready to check your answer. Let's take a look at the answer here. So hopefully you came up with this complex number. Here in this particular problem there was no reducing required. 29 is a prime number, so we didn't have any common factors. Take a look at the work if for some reason your numbers are different. All right, let's move on. So second example. So still looking at division of two complex numbers, but this time both complex numbers in the numerator and the denominator are in a plus bi form. And so again, procedure's the same. We need the conjugate of the denominator, always the denominator. If you do the numerator, it's not going to work because it's the denominator that needs to become a rational number, not the numerator in this process. So that conjugate would be still the same first term of 5, opposite second term, so positive 5i. That's our conjugate. So we're going to take our 2 minus 5i and our 5 minus 5i in the original ratio, and we're going to multiply them both. So this creates a ratio of 1, multiplying them both by the conjugate of 5 plus 5i. So in this one, we're going to have to distribute twice in the numerator because we have to distribute the 2 first, and then the negative 5i, and then we'll do the same thing in the denominator. So we're going to get 10 plus 10i, and then minus 25i, and minus 25i squared. And I'm going to simplify that part first. So here, this would, negative 25i squared would be negative 25 times negative 1, which would be a positive 25. So 25 plus 10 gives us 35. And then our positive 10i and the negative 25i would be a negative 15i. In the denominator, again, I'm going to distribute twice. Distribute the 5 first and then the negative 5i. So that gives me 25 plus 25i. And then I get a negative 25i and a negative 25i squared. So again, I'm looking at this negative 25i squared being equal to negative 25 times negative 1, which is a positive 25. And the positive 25i and the negative 25i will add up to 0. So I have 25 plus 25, which is a rational number of 50 in my denominator. Then remember, we want that a plus bi form. So now we're going to use the fact that 50 is the common denominator of both 35 and the negative 15i. And I would write this as minus the 15 over 50 times the I. And then reducing again, 35 and 50 have a common factor of 5, so that is going to give me 7 over 10. And 15 and 50 have a common factor of 5 also, so that's going to give me 3 over 10 times I. And there's my complex number quotient, answer to a division problem in its simplest a plus bi form. Here is a practice problem for you to try. Again, I would recommend you pause the video and come back when you're ready to check. Let's take a look at the answer now. So here hopefully is the complex number answer that you got. If not, take a look at the work to figure out where your numbers became different. All right, moving on. Third example. So here we're looking again, division of two complex numbers. Our numerator is the a plus bi form. This time our denominator is a pure imaginary number. Does not change our process really. There are a couple of different ways we could do this, but for consistency, we're going to do this exactly the same way as we've done the other problems. So we want the conjugate of the denominator. Now remember, 3i is the same thing as 0 plus 3i. So when you're looking at it in terms of conjugates, your first term is a 0, so that stays the same. And then your second term is the positive 3i, so that's the part that becomes the opposite in the conjugate. And then this would simplify to just negative 3i. So the conjugate of 3i is negative 3i because of that relationship. So we are going to take our numerator and denominator in our original ratio and multiply them both by the conjugate of 3i, which is that negative 3i. Now this one, I would distribute this direction myself, but you can also distribute the 6 and then distribute the 2i if you like that. So we have 6 times negative 3i, which gives us negative 18i, and then positive 2i times negative 3i, which would be negative 6i squared. Then here in our denominator, there's no distributing because there's no addition or subtraction. This is just 3i times negative 3i. So 3 times negative 3 is negative 9, and I times I gives us negative 9i squared there. Now what I'm going to do here, remember, when I simplify this, so negative 6i squared means negative 6 times negative 1, which is a positive 6. That gives me a plus 6. And this gives me negative 9 times negative 1, which is a positive 9. So I want my a plus bi form, remember, and so I'm going to put the real part of positive 6 first, followed by the imaginary part of minus 18i. That's over my denominator of 9. Now I'm going to split it apart, so that's going to give me 6 over 9 minus 18 over 9 times I. And then I'm looking at 6 and 9 have a common factor of 3, so that is going to reduce to 2 over 3 minus, but 18 divided by 9, well that's an even division because 9 times 2 is 18, so this just becomes the whole number 2 times I. So notice there's no rule that says that both parts will turn out to have the same denominator. You just do the math each and every time. All right, let's move on. So here's a practice problem for you to try of this type. Pause your video, come back when you're ready to check. Let's take a look at the answer now. All right, so hopefully you came up with the complex number 1/2 plus I. If you wrote 1i, that's okay, but remember anything times 1 is itself, so we really don't need the 1, so simplest form wouldn't include the 1 in front of an I. And if your numbers are different, please take a look at the work and find your mistake. All right, this also finishes this lesson. You guys have a great day.